Here, we're going to factor some trinomials using the AC method without any prompts or training questions around using the AC method, but let's just talk through these examples, okay? So 10x squared minus x minus 3. Our task is to factor this. Okay, so we notice that the leading coefficient in front of x squared is not 1, it's 10. Okay, so when we have a leading coefficient that's not 1, we can use the AC method to help us out. So what is the first thing I need to do here? I need to multiply a and c together, right? Ax squared plus bx plus c. Okay, and what does that give me? 10 times negative 3 is negative 30. Now, I need two numbers that multiply to give negative 30 and add to give negative 1, right? That's the coefficient in front of the middle term. Okay, so what do I know about the signs of these two numbers I'm looking for? Well, the last term is negative 3, right? So with that negative, I know that my two factoring numbers ultimately are going to be, one's going to be positive and one's going to be negative, right? Because the last term, last times last, has to be negative 3. Okay, so if one's positive and one's negative, let's just think about the pairs of things. So with 30, I just think about the times table, right? I'm like 3 times 10, well, the difference of those would be 7. 5 times 6, that difference is 1, right? So if I want negative 1, I'd have to have negative 6 and positive 5, right, to have it. So because negative 6 times 5 is negative 30, negative 6 plus 5 is negative 1. Okay, so I'm going to use those two numbers, negative 6 and 5, to rewrite the middle term. So, and remember what I said, your two numbers, if one of them's negative and one of them's positive, make sure that you write the negative one first. It makes the algebra a little bit easier, okay? So if I've got 10x squared minus 6x plus 5x minus 3, right? I'm just rewriting the negative x as negative 6x plus 5x. And now I'm going to do factor by grouping. So I'm going to group the first two terms and the last two terms. And in the first grouping, 10x squared minus 6x, let's see, what's common to the numbers? 2 for sure, right? And then x as well. All right, so I'm going to factor out 2x, and I'm going to be left with 5x. And let's see, 2x times negative 3 is minus 6x, right? Okay. And then in this last grouping, 5x minus 3, is there anything to pull out? Well, no. Okay. But remember, there's a little imaginary 1 out front there. So we're considering 5x minus 3 a term in and of itself. So when I factor out the 5x minus 3, then I'm left with 2x plus 1. Okay. Now, remember about the plus 1 there. That's very important because we're distributing 5x minus 3 to the 2x and also to the 1, right, to get our original expression. Let's check it. So we got 5x minus 3 times 2x plus 1. And then as we FOIL this, we should be able to see our expression with the 4 terms come through. So 5x times 2x is 10x squared. 5x times 1 is plus 5x. Negative 3 times 2x is minus 6x. And negative 3 times 1 is minus 3. Okay, so if we combine like terms in the middle there, so we've got 10x squared. 5x minus 6x is minus x minus 3. So that's the original expression that we started with. Let's try this next example. 15y squared minus 17y plus 4. Okay, so again, I have to multiply a and c together. 15 times 4 is 60, right? 15 times 2 is 30, and then we have to double that, so 60. We want a product of 60, two numbers whose product is 60, that sum to negative 17 when we add them together. Okay, so what do the signs of these numbers have to be, right? Look at that last term. It's positive. So we know that either our two factoring numbers have to be positive or negative, one or the other, right? Both of them. And since our middle term is negative, we know that they're both going to be negative, negative somethings, right? But what are we going to have there? Okay, so think about, go through the factors in your head, right? Well, 1 and 60 isn't going to get us to 17, right? 2 and 30 also not. Ooh, 3 and 20, the difference would give us 17, but they'd both have to be negative, right? So that would be negative 23, so that wouldn't work. 4 and 15 wouldn't get us there. 5 and 12, right? Um, yeah, negative 5 minus 12. That would do it, wouldn't it? Because negative 5 times negative 12 is positive 60. Negative 5 minus 12 is negative 17. All right, so we're going to rewrite the middle terms. So we've got 15y squared minus 5y minus 12y plus 4. So when we do the factor by grouping, you're going to get the same result whether we have minus 5y minus 12y or minus 12y minus 5y. And in this case, because they're both negative, it doesn't matter which order at all. We're going to have the same algebraic steps to do here. So I'm going to group the first two terms and I'm going to group the last two terms. And remember, y'all, since we have that negative, if we're factoring a negative out, that last term has to change sign, right? So to think of distributing that negative back through, you've got to have minus 12y plus 4. Okay, so out of the first grouping, 15y squared minus 5y, I can pull out 5y, right? 5y times 3y is 15y squared, and 5y times 1, or I should say negative 1, is minus 5y. Okay. Now, in the second grouping, I can pull out from 12y minus 4, I can pull out a 4, right? So I'm going to have minus 4 times the quantity 3y minus 1, right? And again, when I distributed that negative 4 back through, I'll get minus 12y plus 4, which is what we had in our original expression. Okay, and you notice that 3y minus 1 is common to both of those terms. So I'm going to pull that out, that 3y minus 1 times 5y minus 4. Okay, let's check it. All right, so when we're checking it, we've got 3y minus 1 times 5y minus 4. All right, so in foiling this, 3y times 5y is 15y squared. 3y times negative 4 is minus 12y. Negative 1 times 5y is minus 5y. And negative 1 times negative 4 is positive 4. Okay, so cleaning up the middle term, we're going to have 15y squared. Negative 12y minus 5y is minus 17y. Plus 4. And is this the original expression that we started with? It is. Okay, so these are great examples of how to be thinking about getting this AC method done when the leading coefficient is something other than 1.